So we are back. First, any questions on pointers and just what they are? All right. So let's now start pulling off some of these training wheels. So in the CS50 library, we've been taking these functions for granted, and they've been useful in that they handle all of the getting of input from the user from the keyboard. They even do some error checking, whereby getInt, if you type in, as we've done monkey, it will say retry, 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 until the user actually gives you an integer. But let's focus now on getString, because clearly all this time, getString's been doing some interesting stuff with us with regard to pointers. This is an excerpt from cs50.h, the actual file you've been including. This file lives in a special directory in the appliance, as it would on a typical computer system. For the curious, it happens to live in a directory called /user/include. This is where a lot of .h files are. In fact, if you recall, in a Linux environment, if you type ls, that will list the contents of a directory. And if I do /user/include, notice there's a whole bunch of .h files in my appliance. Among them, over there on the left, is cs50.h. Not all of them are necessarily in the same directory, but we might see a couple of familiar ones if we go to... No, I don't think we've used any of these just yet. Oh, sorry. Oh, and crypt. So we've used crypt there for the Hacker Edition, and then also the CS50, obviously, .h header file. So here it is. Up at the top, the CS50 header file only contains that synonym for string, char star. Remember, we saw this a few days ago. If I scroll all the way to the top, we introduced this keyword, typedef, which we won't use terribly often. We'll use it for one or two p-sets. But typedef just defines a type that char star is henceforth going to be known as string. That's where that came from. But if I scroll now down to the documentation for getString, we've pretty much been taking for granted how it works. But let's actually read CS50's official documentation. It says the getString function reads a line of text from standard input. Standard input just generally means the keyboard, the user, and returns it as a string, otherwise known as char star, sans trailing new line character. So even though all this time we humans have been hitting enter to give the computer a string, we presumptuously, CS50, we just throw away that \n because we don't want all of your strings to have a to have a new line in it. So notice now, if the user inputs only \n, it returns this thing. So double quote, double unquote means the empty string. It is a string. How many bytes are taken up to represent quote, unquote? What do you think? 0 or 1? Any 0? 1? OK, so it is actually 1. Why? Well, every string, even if it's of some crazy 0 length, still has to have the \0. Why? Well, you have to be able to know how long this string is so that you're not just handed some garbage value. But just in case, it turns out that there is, and we've seen this word before, null, in all caps, that represents, as of today, a pointer, a special pointer, the pointer to memory address 0. So a very useful thing about computers is that you, as programmers, are never, ever, ever allowed to store anything at a location number 0 in a computer's RAM. This is simply because so that there's at least one place in memory that is guaranteed not to contain a legitimate value, so that we can reserve that address, 0, as a special constant. So henceforth, if we ever want to check if a pointer is actually legitimate or not, that is there a value there, or is it maybe some garbage value, we're going to start checking for null in all caps. So this function getString apparently returns null if there's an error or if there's no user input whatsoever. Now this is hard to induce, but it turns out, for the curious, if you hit Control-D whenever asked by a program for input, sometimes just hitting Control-D will crash a program, because Control-D typically means I give you no input, but stop asking me. And that is different from hitting Enter, which does give you some input. It gives you \n. Now we have to catch this, and we soon will. So leading and trailing white space is not ignored. So this is to say, if the user hits space, 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 HELLO, you're going to get back the spacebar characters, and so forth. So ultimately, we'll see eventually the implementation of getString, but at least it seems that sometimes this function might return null. So we're going to have to start checking for this. So let's do the following. I'm going to go ahead and create a new file. We'll call it copy1.c. And let's now try to, let's try to actually copy a string rather than just compare. So let me zoom in. I'm going to go ahead and do int main void. And I'm going to go ahead and let's say first ask the user, as before, say something. So we have something to play with. And then I'm going to do a, no more string, char star s1 gets getString. All right. And now I need to start getting into a new habit. We've not mentioned as much, not expected as much, but now that we know that getString could return a null pointer where null is bad, we better start checking for this. So if s1 equals this special constant null, we should probably do something like printf an error occurred, and then \n, and then return 1, or whatever non-zero value. All right, so when might a function like getString ever return an error? When might it return null, rather, to signify an error? What could go wrong? I can think of at least two things. One I already answered. Control D. So whatever that thing is, Control D apparently can do bad things, and so null might get returned. Now, this is not a terribly worrisome case, because most humans are not going to accidentally hit Control D. But again, there's another more reasonable approach. How else could getString fail potentially? If the string is too long, right? If I spend half an hour typing letters at the keyboard such that I type in like 2,000,000,001 characters or 4,000,000,001 characters, more characters than I have bytes of RAM, it's possible that getString, which happens to use that function called malloc, memory allocation, which we'll see before long, what if it just can't give me 2 GB worth of memory just to fit some user's crazy long essay? So how does getString signify that error condition? It's got to return a special value. What's that special value? It's going to go ahead and return null. Now, in the past, we might have returned false to signify that something went wrong. But if getString is defined as returning a string, but a string we now know is just a pointer, we can't return false, because false is what? It's a Boolean. We have to return a pointer, so we need C to give us a special pointer that's reserved for error conditions. And so it commits to returning null, so now we can check for this. So this is, as simple as this is, this failure to check with an if condition, something as simple as this in a program, is a huge source of bugs in people's programs, as well as relatedly a huge source of hacking opportunities if you are not checking the values of pointers and are potentially doing things with pointers that are just garbage values. And we've already talked about the notion of garbage values. They apply to pointers as well. All right, so now let's go ahead and make a copy of this thing. I want to make a copy of S1 and call it S2. So let me say char star S2 gets S1. All right, on the left-hand side, I'm allocating a pointer called S2. I'm assigning it the value of S1. And now I'm going to go ahead and do printf. S1 is %s \n, and paste in S1. And let me do the same for S2. S2 is %s, S2. OK, and let's try this. Let me scroll down. Let me go ahead and do make copy 1. Oh my god, so many errors. What's wrong here? So a couple things, right? I skipped this part. So include cs50.h. All right, now I need that for sure for getString. Let's see if that solved all my problems. This does not mean I have 6 some odd problems. Rather, I could just have one that has a cascading effect. Make copy 1. Oh, printf. Damn it, need that one. All right, so it's probably just a good idea to get into the habit of almost always using these things. Let's see if I've solved all my problems now. Make copy 1. Whew. OK, so copy 1. Enter. Say something. Hello. Ooh, nice. My copy program works. OK, but not quite. Let's try something to prove that I'm actually not so good at this. So let me try to capitalize just one of the strings. And I'm going to do this as follows. I'm going to capitalize just S2. And how do I capitalize it? Well, I'm going to capitalize its first letter like this by 2 upper. Can I do this? S2 bracket 0. You might have used this function before in Caesar or Vigenère. Or if not, 2 upper should just uppercase this a letter. But let's see if I need to include anything. Let's try to run this. Implicit declaration of function 2 upper, so no problem. So 2 upper is a string function. So let's go back to the same documentation. 2 upper, C type. So here's another file. We actually glimpsed that a moment ago in my directory. But I need to do C type. So let's go up here, include ctype.h. Now let's zoom in on the bottom. Try recompiling one last time. Looks good. Let's run copy 1. Hello. Now, kind of interesting, but hopefully less interesting, having just spent all this time talking about what a pointer is and what a string is. Why is this program flawed? I capitalized S2, but apparently the computer decided to capitalize S1 also. But why is that? They point to the same place. Exactly. So what's really happened? Well, I didn't type goodbye, so let me delete this part of that story. I did type in HELLO. I did create S1, and S1 is apparently pointing there. But when I do S1 equal sign S2, or rather S2 equal sign S1, what's really happening? I'm not copying all of this. I'm literally copying S1, putting it into S2. So what ends up getting written here? 1, 2, 3, 4. 1, 2, 3, 4. So when I go to S2, bracket 0 is at what memory address? 1, 2, 3, 4. Where is that on the board? Well, it's over here. So what did I change the H to? A capital H. But wait a minute, that's the exact same chunk of memory that represents the S1 string. It just so happens that now I do have copies, but copies of the pointer, not copies of the whole string. Now, as an aside, I've been making up 1, 2, 3, 4, 4, 5, 6, 7. The reality is these numbers are almost always uninteresting to us. So generally what the world does, as we'll see in Clay before long, is the world just says, if it's a pointer, let's just go with something much more intuitive. If that's a pointer, just point on the board to whatever it is you're pointing to in memory. So we would typically draw pointers as arrows pointing at something, but realize that what's really inside of here is a number, like 1, 2, 3, 4. But it's kind of uninteresting to keep making up fake numbers. So we'll typically just draw arrows. So just conceptually, what's the solution to this copy problem? How do we actually duplicate the string? What do we need to do in order to make a genuine copy of S1 and call it S2? Sorry? Yeah. OK, we need to individually copy each character, but into what? Yeah, so really what we need to fix this problem and finish this story is we need the same amount of memory that has as many locations. I don't know what's here by default, because again, just as with variables, when you allocate memory, you're going to get a whole bunch of garbage. It's up to you to populate it with actual values. So that begs the question, how do you create an array of a specific size dynamically? How do you dynamically allocate memory? Well, it's actually pretty easy. Let me go up here, and I'm still going to check null. But before I do this copy, what I'm going to do is this. I'm going to first say S2 is not S1, but rather char star S2 equals the return value of this fancy new function malloc. And just to oversimplify for a moment, I need 1, 2, 3, 4, 5, technically 6 bytes. So I'm going to hard code this ever so briefly. This function, malloc, called as follows, will hand me back 6 bytes of memory, which pictorially would look like this. They're at some other memory address, but how do I know at what memory address malloc allocated me memory? Via its return value. So what malloc does, if it can, is it allocates memory for you. It then returns to you the address of which of the bytes of memory it just allocated, which of the 6 bytes. The first. And it's going to be up to me to make sure I put a special sentinel value, a special \0 at the very end, so that I don't forget how long this chunk of memory is. Now, I probably shouldn't hard code something like 6. How can I decide dynamically what the length of S1 actually is? Yeah, so strlang of S1, like this. OK, so +1. So here it's OK to hard code that +1, because you always need +1 byte for that special \0. So to be clear, when you call string length, as you've done for a week or so perhaps in your own code, it returns the actual human length of the string. It does not include the \0. So when you're allocating memory for this, you actually do need to do so. Now, as